Hi everyone, welcome to NDC Sydney 2020. I hope you had a really good session so far and that you're looking forward for other sessions after this. It's already about halfway through the conference. And what I'm going to show you today is machine learning simplified for developers with ML.NET. Before I begin, I am Jernej Kavka. You can just call me JK. I'm a senior software architect at SSW. You can follow me on Twitter, GitHub, my blog jkdev.me, on LinkedIn. I am also organizer at Brisbane AI User Group, newly baked AI MVP. And today I'm doing a lot of .NET Core, EF Core for my clients. But at night, I try to do a lot of ML.NET, cognitive services, and things like that to basically not just to learn AI, but also to teach others about how to get started with machine learning. And this is roughly my current setup now that we are in these weird times. I think somebody needs to unmute. All good now. So this is your audience. When I look straight at you, I'm actually looking at my future overlords, our robots, and I'm teaching machine learning to please them. And when I need to get some exercise, you could go outside, but I just prefer to do it in VR. And I'm actually looking forward for the Oculus Quest, which should be on the way. So if you think about VR, I think right now it's the best time to get into. And as I mentioned before, in my free time, I'm trying to teach people about machine learning. And one of the products of that is Cognitive Studios, where you can actually try out cognitive services for yourself with your own accounts, with your own data, without needing to install anything or even have Postman. And it links to all of the documentations for all of the things you're using. If you want to get started with cognitive services, which is a bit of like a black box machine learning, then I recommend you to do that. All right, so what I'm going to cover today is I'm going to tell you a little bit of my story, how I actually got into machine learning, how I got into ML.NET, and why I'm preaching about why you should try to get into machine learning and why it is not that hard anymore to get into machine learning. Then I'm going to go a step backwards and I'm going to start talking about machine learning. Because if I show you ML.NET and how easy it is to do machine learning with ML.NET, you'll be like, oh, okay, I do a couple of clicks and that's good. But if I show you first all of the pain points and then show you, hey, this is what ML.NET does for you, you'll be like, oh, wait, all of that is happening behind the scenes and you don't have to worry about it. Awesome. So that's roughly the agenda. And at the end, we're going to have two demos. One is a new little surprise. And let's get started. So my goal at the beginning was actually in 2004. And what I wanted to do is, when I was even in high school, I wanted to, get the transactions from my bank and look at the bank transaction descriptions and then map them into categories, because I wanted to know where the money is going so I could do better budgeting. Now, at the time, I had this bank transactions, and then when I wanted to basically map them, what I did, I took Excel and then I enter all of this stuff manually. And I was actually accurate by a couple of cents for months, but you can imagine how long it took me every day to, make sure that all of my receipts were accurately tracked. And, in about 2008, 2009, 10, I started using C#. And I was like, oh, wait, I can now automate this. I can, instead of looking manually at transactions, I can read the file and then update the Excel based on that. But then what I realized is it's actually a really hard problem if you just do if statements. And then later I upgraded to regex. That didn't quite work well because more and more different transactions comes in, and then I have to add more and more rules. Then I tried to write my own engine, my own rule engine. And that took a while to implement. And then I realized that I also need to implement a system where I can actually learn new rules on the fly to make categorization. And then at some point in 2016, I was like, am I now trying to just build machine learning from scratch just to solve my problems? And I was like, okay, let's just look at existing solutions. Can I just use actual machine learning to solve the problem? And I looked at a couple of them, and what happened is I realized that you just don't simply learn machine learning. And to understand why, imagine that machine learning is like a rabbit hole. You try to learn something, and then you realize, oh, this topic is really deep, and I'll need to learn a lot of it to understand it. But then you realize while you're learning that single topic, oh, wait, now they're throwing some phrases in my direction, and each of them is like a huge rabbit hole, and that rabbit hole throws in another words than when you need to learn. And also another rabbit holes. And then what happens is that my weekend project ends up being a couple of weekends of, and then at the end, I was just like, look, I don't have time for this. Is at some point, I just need to say enough is enough. It doesn't seem machine learning is for me. And it became one of my failed dreams, like a lot of other things. But you know what? Then about 2018, Microsoft released ML.NET, and I was a bit skeptical until I saw this. So what they claim is that you can use machine learning without any prior experience with machine learning. And I was like, okay, you got me, Microsoft. I'll have a look. So what is ML.NET? Well, it turns out it's a machine learning SDK that works offline. That really ticks some boxes for me. I really love having the ability to run things on my local machine. It's simple yet powerful, like I think all of the C# libraries should be. It already has been powered by several Microsoft products. To my knowledge, it's Visual Studio, Power BI, Office, and a couple of others. So it's not like that this came out of the blue. They already used it in some of their products and then made it available to other developers. Now, if you already have a data scientist in your team or someone who already does machine learning, they already might have some models. So rather than using ML.NET to do training of new models, you can actually consume TensorFlow and Onyx. So you can actually leverage other machine learning models as well. And one of the most awesome things that actually put me on this journey is the awesome samples on GitHub. In fact, one of the GitHub called the GitHub issue classifier got me to solve my problem in about 1 hour. And I was like, wait, did I just solve a problem that took me days, weeks of work with different kind of variation, and now I just picked up a that Excel, instead of their data, I put my data, I retrained it and tried out, and it was like, wait, works. I can change numbers in it. It just works. It's like regex, but it actually learns over time. And that was an amazing feeling. Just being able to do one simple prototype in an hour and it just works. So, okay, now I hope that I hooked you up a little bit on ML.NET and that you'll be very eager to see the demo. I'm going to take a step back and show you what machine learning is, so that you not only have a bigger appreciation later, but you also actually understand roughly what's happening behind the scenes and what is all the fuss about machine learning. So to start this simply, let's look at what machine learning is. So machine learning is, if we look at the classical programming as an example, in classical programming, we first start with rules, which could be your specifications, and the data, which could be the input forms on the website. And then in the middle, we write our own algorithm, which for the data spits out a specific answer. Now, machine learning is a little bit different. So what happens is we are swapping the rules and the answers. And the reason why we do this is what we do is we have all of the data, most of the data, like most of the things that are happening with some edge cases and stuff like that. And we have answers to all of them. And then we put into machine learning algorithm, which trains based on that data. And then it gives us, as a result, rules, which we can then use in the classical programming to put in current data, and then we get back answers. Now, an example of that, a very simple one, would be a game called rock, paper, scissors. Now, if you do AI in classical way, which means lots of if statements, then you do if rock, then paper. If paper, then scissors. If scissors, then rock. Simple, right? And you probably wouldn't think about doing machine learning on this kind of a simple app, but I did it anyways. So with the rock, paper, scissors machine learning, what you do is you specify in one column what would be the opponent's move. So for instance, if opponent does rock, you should do paper. If you have paper, you should do scissors. And then it takes this data, trains based on this data, and then it returns a model which can be used when you put in data, you get back the result based on the data that it learned. So this is a very simple example, but what if we complicate it a little bit? This is a game called Rock, Paper, Scissors, Lizard, Spock. And let's say that you're too lazy to actually read about the rules, but you actually have a Excel sheet with all of the games that have happened, and you have what the opponent did and what the winner did. And then what you can do is you can just take that Excel, put it in the same training algorithm that you did before for machine learning, and all of a sudden, your model understands how to play rock, paper, scissors, lizard, Spock without you needing to know the rules. Machine learn it for you. And this is kind of at the power of machine learning. It's a simple example, but you can imagine that if things are happening quickly, like if social gaming changes the rules for rock, paper, scissors, you don't have to write a new app for it all the time. You just get an Excel and let the machine learn the rules. And now that we kind of see a little bit about machine learning, there's another thing that helps people to understand how machine learning works as a whole when we look at ML ops. That is machine learning operations. And when we start with machine learning, we first start with our training data. Then we move that training data into a machine learning training algorithm, which results into machine learning model. Now, this model basically represents like a knowledge about the training data. It knows for a question what could be the answer. It knows how to get to the answer based on the data. But this is not where the journey ends. You also need to deploy this model. You deploy it to your desktop and mobile apps, then you deploy it to web, to IoT edge, and the users then use the application, or the machines use the model. And this is still not the end of the story. The important part comes here. When users are using the application, they give us some feedback, and this feedback then can be transferred into improving data. Then improvements can go back into the training data, and now you repeat the cycle. And this is how you can get a machine learning that gets better and better with each iteration. And this is something that a lot of people don't understand, how and why machine learning gets better over time. It's because we're gathering new data and we are improving the existing training data. All right. So now we looked at machine learning super far away bird's view, then a little bit on how the operation works. But let's take just a little bit closer look into the machine learning itself. Now, it's a little bit harder to define what machine learning is when you look a little bit closer. It's almost like asking, hey, what is programming? Well, are you interested in imperative programming, functional? You know, they're quite different. So with machine learning, we also have similar kind of divisions. So on one hand, we have supervised learning, which means that the data we're using have labels. And to better understand what that means is, let's look at the classification, which further divides into binary classification. And one popular example is essentially sentiment analysis, which tells us, for instance, is a tweet positive or negative? So our data would have a bunch of tweets in one column, and on the other column, it's going to say, is it positive or negative? And then machine learning tries to learn what is the common denominator for positive and for negative. And then we have multi-class classification, where for set of inputs, we're trying to figure out different kind of categories. So for instance, based on certain classifiers, we want to figure out whether something is an apple, pear, or grape. And for these simple models, we actually might just have decision trees that are generated by the machine rather than neural networks. But neural networks are also very popular way of doing multi-class classification. Another popular one is regression under supervised learning, which, for instance, you want to predict house prices. That means you have several attributes for the house, and then you want to guesstimate how much would that house cost. That is not the same as predicting future costs, which would be used for, say, Forex, trying to predict the future prices of stocks, which is a time series prediction. All right, so we have, on the other hand, unsupervised learning, which is unlabeled data. We don't strictly have an answer for the data when we are putting it into machine learning. And this is a bit of a harder one to learn, but one of the simpler examples of that is clustering. And clustering essentially allows you to do product recommendation. So if you buy a product recommendation would look, okay, to which of the cluster of users that bought similar products are you in? And then when it finds the right cluster for that user, it can then look at, okay, what products these users have bought, and then it can give you suggestions for what products you can buy next. Then we have dimension reduction, which is a very interesting one, especially if you like graphs, because what it can do is try to reduce the amount of dimensions you have in your tables. So for instance, you have hundreds of columns, and dimension reduction can try to figure out which columns are actually important based on certain criteria. And it can reduce to far less, and then it can even auto generate some graphs out of it, and the humans better understand data. Now, one of my favorites one is reinforced learning. Reinforced learning is essentially try, fail, learn, repeat. And this means that it tries to learn on the fly and to better understand where that could be used is, for instance, for self-driving cars. It's constantly getting data from real roads and from virtual worlds, while driving in virtual worlds, and it tries to learn what it did wrong and how to correct it. Most of the AIs that I have specified right now, they basically have a training data, and then it tries to learn from scratch to get a model. You have with deep learning, you have the ability to update the model, but generally you just generate the whole thing from scratch. With reinforced learning, the main point is that it learns over time. And it's also used for game AI, although usually in game AI, at some point the model is fixed. So it doesn't change. They might change it in the background and push it as an update, but it's fixed on the client side. All right, so this is not a full picture of machine learning. And there's a lot of caveats to here. There's a lot of subdivisions. There's a lot, like really small fraction of everything there is. But this hopefully just give you a little bit of a feel how why it's sometimes a bit hard to talk about machine learning, because each of these parts can be a completely separate discussion. But if we want to start machine learning, we actually need to look at a specific type of machine learning to actually understand how can we get started. So I picked up the multi-class classification, and I'll zoom in. And what do we need to know about multi-class classification is that it has different trainers. So what trainers are is, how do I read the data and then train a new machine learning model based on that data? And we have a bunch of them. And the reason why there are a bunch of them is because each of them have their strengths and weaknesses. Some of them will be good for really big data. Some would be good really for small data, for a lot of labels or different categories that it tries to predict, and some for small. So they all have their pros and cons. Now, I won't be talking about them, but if you're interested, you can go to the Microsoft documentation. They're really good at describing them. And if you're really interested to know what is the process for data scientists to get started with machine learning every single time they get a new data set, that's roughly what they do. It's just like, okay, I have this data, and then they go through a graph to try to figure out what would be the best trainer. And you can see that some of them is like, oh, is it not working? No? Okay, try this one. Is that not working? Well, try this one. So it's not really an exact science all the time. It's a little bit of trial and error, especially if you don't have the experience. So if you struggle at the beginning a little bit, that's fine. You know what? At the end, you'll see that you don't actually have to struggle when you do trial and error. All right, so ML.NET actually covers everything here except for this one. Unfortunately, my favorite one is not yet included. Hopefully it will. Okay, so how do we actually get started? Now, I have dumped a lot of information onto you on, what machine learning is, but how do you actually start? So you start with a scenario. So a scenario, for instance, would be, is a tweet positive? That would be a sentiment analysis. And for sentiment analysis, you use binary classification. You're just interested in yes or no. So, for instance, we want to categorize bank transactions. That would be multi-class classification. Then we want to do house predictions. That is regression. We want to do product recommendation. That's clustering. If you know what is your scenario and then try to figure out what is the most appropriate subtype of machine learning, it allows you to focus on what you need to learn rather than trying to learn everything and then realize I have no idea how to use my knowledge now. And there are a few caveats before we finish off the machine learning section. Machine learning won't actually solve your problem magically. You kind of have to understand your data. Now, that doesn't mean that you need to understand everything, but you need to understand enough to guide your machine learning toward the right solution. So if you do a multi-class classification, you need to be able to look at the row, look at the different columns, and then see if you can make a good guesstimate of why the column that you're trying to predict, you can actually predict just by looking at the other columns. If you can't, well, machine learning might still be really good at it because it might be able to find correlations that you can. But generally speaking, the machine learning model probably won't be good because if humans struggle with classification with a couple of rows, then machine learning will probably struggle as well. And start with something simple like classification. You can also start with regression. It's a tiny bit harder than classification, especially if something goes wrong, but classification is a really good way to start. All right, let's finally go into ML.NET Model Builder. So as mentioned before, you can use it without any prior machine learning experience. And when you try to start, it actually greets you with various scenarios. And this is really good because it makes you think, for what I want to use machine learning for. And when we look back at the cycle of training data, training algorithms and model, ML.NET gets in the middle between your data and the generated model. There's still a tricky thing, like I mentioned the trainers, right? ML.NET still makes you choose the trainers, and you're like, okay, which one should I pick? Are there any questions? Somebody unmuted? Oh, okay. All right, so you don't have to worry about that because there's also a ML.NET model builder. So what it does, it's like a wizard on top of ML.NET SDK, and it tries to pick the best scenario, best trainer for the scenario and the data that's been given. And it can change over time, the trainer, and it allows you to do quick prototyping, which I'm going to show. And to have it installed at the moment, it's preview. So you have to search for preview features on top. click on that and make sure that it's enable ML.NET Model Builder. If you don't have that option, try using ML.NET Model Builder and click download and try to install over there. If you still have problems, get started button may help you out. I have done some minor changes, but I think they're going to stabilize the way you get Model Builder by the time it's going to be out of preview. All right, so to get started, there's a few things that that we need to have. So first, I'm going to have a training data set, and my training data set is coming from my bank, which was imported into a financing service called Troubleshooting, which allowed me to do manual classification. And I did the manual classification for the last 3 years. So I had a lot of data to work with. And then I exported it into CSV. I could use the REST API, but I chose to just go CSV. It's simpler. And this is roughly the data we're going to have. We're going to have over here date column, account, whether it was debit card, Visa, category. This is what we're interested in. Now, we also have tax, which is something that we manually entered, and this is going to cause a bit of a trouble, but we'll be able to fix it pretty quickly. Expenses, income, currencies, a couple of other columns, and the last one, description, which is the most important part. This is what we're going to use to try to do the actual prediction. We can use all of the attributes, but in the end, we'll see that this is actually the best column to do predictions. All right, finally, demo. So I'm going to open up an empty Visual Studio, and I am going to go new project. Now, what you're going to see is if I search for machine, you cannot find anything. If you start searching ML, we don't find anything either. So to get started, you actually have to have a project already. I'm going to create NDC Sydney Talk, create. And now we have a console application. Now I'm going to do right click, add, and now over here we have machine learning. So when I click on machine learning, we're greeted with a couple of things. We have text classification, value prediction, which is regression, image classification, recommendation, and object detection. These are all the ones that are built in the model builder, and you can do everything from the model builder. And down below, we have actually some examples of how to do other scenarios outside of model builder that haven't been quite yet polished to be using model builder, but in the future, we might also be able to use them a bit easier through model builder. Now let's get started with text classification. Here you can select a couple of different environments. If you're interested what the different environments, we can look at actually image classification. Over time, they might add those. So one of the options is local GPU, Azure, and CPU. But for text classification, we only have CPU at the moment. When we select that, we have the option either to get started from a file or from a SQL Server. In my case, I'm going to choose file. I'm going to select this, verify that in the right folder, and I'm going to open my data set. Now, down below, they have a nice view of the data set, which is really nice. And what I'm going to do is I'm going to select a category. I'll do that. And you know what? I'll do it 30 seconds. Now, if you struggle to figure out what would be the right time, you can put 0, start training, and then it'll give you some hints. Now, the only comment I would say here is that this should say use 10 seconds plus. if your dataset is 10 megabytes or less, because it really depends on your machine, how long it will take to train. So in this case, I think the file is about a meg or two, and it takes about 8 seconds for one of the trainers to complete. You want to complete like 2 or 3 trainers, and you can see down below over here. We have one trainer, which is average perceptron over, done in 8 seconds. One is maximum entropy, done in 5 seconds. So next one, I'll just go with 15 seconds because 2 of them is, good enough. Just in case if the second one is a bit better than the first one. Model Builder is pretty good at determining which of the trainers would be the best pick before it even start training. So that's why you don't always need to run all of the trainers. All right, so that actually done, like the whole first part of my talk has been done with that one button click. Now I hope that sinks in a little bit. Everything that I explained until now, that one button click. Isn't that awesome? And when you get next, you already can play around with your model. So that was a dream 10 years ago. That was unimaginable years ago. Having, just a couple of clicks and bang, not only I have a model, you can just quickly try out in the same application that generated the model. But you know what? Before I continue onwards, there's a couple of things that I want to cover. Like this tax, there's a big problem with it. Problem with this is this was manually entered. So for instance, when I get a bank transaction, this is not filled in. And in order to fill this in, I actually need to know what that transaction is. I need to know the category. I need to know almost everything about it. So it's not quite useful. But you know what? We can fix that. So you could decide to go 2 ways. One is you can try to merge the text column with category, and then you have a lot more categories or labels to predict. That can be a good thing or bad thing. It really depends on the scope. You might want to play around with that. Or you could have 2 different models. Or in my case, I'll just ignore that. And I'll just say, I'm happy to just be able to classify just categories. And I'll just remove the tags for now. I'll move this to 15 seconds, train. And what we should see now is that the accuracy is actually going to drop quite a bit. It's going to drop for about 8%. But you know what? That is good because this is giving us more realistic accuracy for our model. That means that we won't have the problem of, oh wait, we need to figure out what that input tag should be without having any way to actually know that. We don't have any of those variables. We can just take the actual transactions from the bank and put it into machine learning model, and it should spit out a category. Now we can do a little bit better now. If we add a little bit of data science, what we can do is I can improve the score just by a tiny bit by removing a column. So I'm going to remove date. And the reason why I want to remove date is it's an incremental value. It never quite repeats itself. It just increments. And this is good for forecasting and for some other machine learning. But for multi-class classification, repeated values are actually better than incremented or random values. It can actually confuse the multi-class classification because it does not know what is the correlation between this incremental date and category. It just doesn't understand. Now, if you convert it into day of the week, then it will be able to figure out, okay, on Saturday you have coffee and breakfast in the morning. But with the date itself, it has no idea. So I'll remove that. And I'll do training. And what we should see roughly is about 1 to 2% accuracy increase. So we had 86% before, and now we have 86.3, 86.9%. So a little bit less than 1%. But you know what? We just removed another column that we don't have to enter anymore. And we got better accuracy. And we can go push it even further. So, you know, what you want to do is you want to make your model as simple as possible for inputs, at least at the beginning when you don't quite know how, what are the boundaries, what is the best data. You know, just keep it simple. And what we can do is, I know that I have no income. So here, everything is going to be 0. All of the currencies are the same. So I can remove that one. And the in-main currency, because I don't have income amount, is the same as expense amount. I can remove that. And main currency is also always the same. So I can literally just remove all of that. And we're starting to get better and better the input to the model simpler, but what's going to happen is that the accuracy does not actually reduce. So we can see, in fact, it got slightly better. Now, the reason it got slightly better is every single time we click train, it splits the data 50-50. 50% is for training and 50% is evaluation, and it does a random split. This means that every single time you run, you might get slightly different results depending on your data set. The more unique values that you have, the more likely it is that it's going to be a bit more different than on every run. So I would really recommend that if you find some very unique values, that you try to at least duplicate them once. All right. Now this is almost perfect, but I understand my data. So I'm going to put just one more data science over here, and I'll look at this column, account. And what this column does is it basically tells us if something was purchased with a credit card or debit card. Now that sounds inconsequential, right? But what it means is if I switch from credit card to debit card, all of a sudden, all of my results with debit card are going to be worse. Now that's not what I want. It's, you know, it shouldn't matter what kind of card I'm using. So what I'm going to do is I'm going to remove account as well. Now, if you want to keep the account, make sure that you're actually doing similar or same transactions with both of the accounts, so that machine learning can understand that the account is not strictly tied to the category or to the description. But in this kind of cases, you probably are better off just removing it. Now, what we'll probably see is it's going to be slightly worse off, the prediction. But I think, considering that we can now switch between credit card and debit card, I'm actually happy to sacrifice about % of accuracy. I'm happy with that. Now, the reason why we're getting 85% of accuracy is because this is real data. It has conflicts, it has ambiguous transactions, it has unique transactions that it needs to decide whether to put it into training data and evaluation. And if you put more effort into the data, you get better results. Now we're getting here. Now I would want to go to code and generate, but there's something that I still want to show you. So if we predict this particular category, this particular description, and we bump up the values, I'm going to be closer and closer to a point where I no longer know what is going to be the category. And that's because I did my training data in such a way that any high value is actually a transfer. So I literally put just a couple of transfer rows that just have high values. And what that caused is that when the model is not quite sure where to put the category, it will just look at the expense and say, oh, wait, is it more than, say, 10,000? Oh, okay, just put it in transfer. It's fine. It doesn't matter what the description is. And that is not really good. I mean, in real life, you probably won't have that kind of data, but it is really good to know that machine learning, if there's a shortcut, it will find it. And if that shortcut is bad, like in this case, you might want to be at least a little bit aware of it to cover the edge cases. You can imagine it as being as a lazy developer. Okay, so what I'm going to do is I'm actually also remove the expenses, because what I realized with experimenting with data, with, trying out different things, I actually realized that, you know what? This expenses, this amount actually doesn't tell me a lot. It doesn't really actually help me get the category. And in fact, I'm getting almost exactly the same accuracy without it. So why have an additional input if you can have pretty much the same accuracy with just one column? So with just one input. And I'll go into cheat sheet and I'm going to copy this and I'm going to paste this, and this should be investment. I think this one should be education. Yeah, education. And I'm going to try this one. I think this one should be utilities. Yeah, home and utilities. So, I haven't written any code. It's just, it finds those things. So now I'm happy. I'm going to add this to my solution, and let's have a look what it does. So I'll need to do a little bit quick, and for Q&A, I'm going to have a Q&A at Ask Me Anything at SSW TV. There's a channel on Slack, and I'll have that over there. And if it's on YouTube, I'll have it there'll be a link on YouTube. So what I'm going to do here is I'm going to quickly explain what we have, new projects. So the model over here is the inputs. We have everything done from, it generates all of the columns that we had in our original CSV. And that's because it's actually also allowing you to retrain the model. So it needs to know the full structure. And then we have the output, which gives us the prediction and also gives us a score. I'll get back to it when we run the application. Then we have consume model, which gives us an example of how to consume the model. And we can see it's really simple. We have a machine learning model. We read it from the file. We can ignore the model input schema in our case, and then we create prediction engine. So we get the machine learning model deserialized, and you can see it's kind of like a transformer. It transforms input into output. And based on input and output and this transformer, we can get a prediction engine. And this is already pre-generated model. Now for the console application, and I'll switch to here. Now, I think there's a bug in Visual Studio at the moment. Okay, it's running. NuGet doesn't get restored for the IntelliSense, but it's still working. So what it does is it tries to make a single prediction, in this case Spotify, to tell us, okay, it's leisure. And over here, it gives us the score of all of the possible categories that we could have. But it's pretty ugly view. So what I'm going to do instead, let me close this and try again. Yeah, this is preview 3.1, I think. There's a preview 4 at the moment. I think with the preview 4, this issue is fixed. You can see IntelliSense works now. I'm going to take this snippet over here. And what is this going to do is it's just going to replace all of the outputs with my own output. And if I run this, I need to add link. Now, isn't this nicer? Now you can actually see a very similar UI as before. And if you're interested how this works, this is because we just need to specify categories as they occur for the first time. So the first one was leisure, the next row was other, then the fourth row was transport and things like that. You just, if you have the list of all of them, you just do, you select all of the categories and then do dot distinct. All right. Now, if I go back to cheat sheet, I'll copy this one. I'll replace the sample, and we'll see in a moment why. So this is not going to detect as investment, which is fine. But one of the common issues that I found is, what if we change one letter? Well, now it was way off. That is a very good reason why this is happening. And it's just a bad coincidence on how the data, specifically the description, is. If there are too many repeatable values in a specific column, the ML.NET Model Builder will decide to use that column as categorical hash. That means any change in the description will result in a completely different hash. And that's because there's a lot of duplications going on. Now, you could remove duplications from the training data itself, but if you have this kind of problem, you might want to keep those duplications and fix how the model is generated in the first place. So I'm going to go to Model Builder, and here's all the code for how the model is generated, but I'm going to look at the build training pipeline. And over here, you can see we have description, and it's defined as categorical one hash encoding. So what I'm going to do is I'm going to modify this little code to be actually featureized text instead. That means that it actually splits up the text into multiple tokens rather than make a hash. I'll copy Model Builder. I'll go here, do that, create model, and run it. Now, this may take a few seconds, but once this is done, it usually works slightly faster than this. And you can do it. Come on. That takes way longer. Ah, okay. It's working out. So what we have here is it's now almost 100% sure it's investment. We fixed the model. Now we can comment this out. I can remove this. I can even remove all of this. You can just have a simple text and bang, it still works. So if you have this kind of problem, don't worry, just generate the model. It's fine. You can fix it with the in the model builder code. All right, and just one note before we switch back to slides. If you want to try this at home and you have a small data set, just keep in mind when you do training, if your data set is less than 100 lines, it won't work. So for instance, I have here a rock, paper, scissors, and what I did is I just duplicated the data until I reached more than 100. So if you have that issue, that's what it is. Just duplicate the data and it should work. All right, let's go quickly through. So if you're on Linux, Mac, or on Windows, you want to use it in Docker, you want to make it like ML ops where you generate the model all of the time. There's actually AutoML CLI available, which does exactly the same thing as the model builder. You just do .NET tool install -g MLNet. And what it does is does exactly the same thing. It generates the same project with this in a solution, and it also generates the model with all of the code. This example over here doesn't ignore all of the columns that we have ignored, but generally speaking, it does the same. And there's also a sample that I did is Blazor WASM, which is a client-side Blazor. And if I go over here, you can play around with this. You can actually see the proof that this is fully offline, that it downloads the model, and I can copy, paste, predict, and this is fully offline. It doesn't download, it doesn't actually do any request to the server. So if you're interested in doing C# and doing client-side code and ML.NET, you can do all of that, except for training. You can do training. So in summary, we have imported CSV file or SQL Server, tweaking columns to get better results with a bunch of columns, generated project with machine learning, tweaking generated code to make the description works correctly, and fix some minor issues with dataset over below 100 rows. And if you're interested for more, I have done a machine learning interview with Richard Campbell talking about the challenges developers had and what they should think about when they start. And I have done my goal. Thanks. No worries. Also, I'll share the links to several things. Any other questions? Not, I'll stop sharing. Which is